So the way we do this in Megastat, we go to Add-ins, Megastat, and under confidence intervals sample size, as I mentioned before, we're going to start with sample size determination. And this is a problem associated with mean. We're only going to do mean and proportion. And notice how we know this one's a mean problem because we have a mean and a standard deviation. Our margin of error is not in percentages, so it's not a proportion problem. So the mean that we have in the new sample, if we go to sample size mean, all it needs is the error, so you can just put 5 seconds. The standard deviation from the previous sample was 10 seconds, and it says 99% confidence. Okay, notice it's going to give us the and it calculates, but it'll also round it up. Okay, hit OK, and you see it's going to be 27 if we round it up. So the answer there is 27. Just be careful, it's not, the answer is not 26.54, it's actually 27 because we always want to round up when it comes to sample sizes. Okay, so, and this shows it to you as a screenshot. Make sure you're in the sample size mean tab. All you need is the error that you're willing to take, so you can always change that and kind of see how it changes. You can always change confidence level and see how that changes. In fact, let's do that right now. What if I was willing to have a little bit less confidence? Let's do 90%. What do you think is going to happen? If I don't have to be as confident, I can probably have a smaller sample size, only 11. Okay, so that's what happens when you change the confidence level. Okay, so I need a sample size of at least 27, and don't forget to always round up for sample size problems, even if it's a proportion problem, which we'll get to next. Okay, here's another example. You were just hired on by IBM Global Services as a consultant helping a product design and marketing organization. They want to change some of the materials used on one of their consumer products, a countertop rotisserie. Jimmy Jack, one of your fellow consultants, selected a sample of 9 of the new rotisseries for testing, and being a graduate of this class, you're leery of how Jimmy Jack determined his sample size. Historically, the rotisseries yield a standard deviation of 2 for the evenness characteristic, assuming that a difference of, or error, margin of error of 1 is acceptable, and a minimum confidence level of 95%, what should the sample size be? So let's go back to Megastat. Confidence interval sample size. You can tell this is a mean problem because I have a standard deviation and a mean. Okay. The error I'm willing to take is 1. Standard deviation estimate is 2, and 95% confidence. And basically, so a sample size of at least 16 is what we need there. And if you ever see those number signs, you just have to drag it, make a wider column. So 16 is the sample size I need. Okay, and this just walks you through with screenshots if you want to just use the slides. Okay, we can do the same thing for problems that involve a proportion rather than a mean or average. Here's the equation for that, which it's great that Megastat is doing that for us. Just some notation. The population proportion, the symbol for that is pi, and the sample proportion is a small p. Okay, so pi for population proportion and small p for sample proportion. This is what goes into it, but Megastat's going to do that for us. We basically have the error. The z is going to represent our confidence level, and we need an estimate of the proportion, which if we don't have it, we will always use 0.5. Okay, so just remember that. If there's no proportion in the problem, then we just use 0.5 when we're doing Megastat. Okay, so let's look at this problem. I want to find out what percent of all university students, so population proportion, pi, use Spotify. I want to be 95% confident, and I'm willing to have a 3% error. So notice the 3%. That means your error is going to be 0.03 entered into Megastat. Okay, and I don't have any kind of sample proportion or estimate of the population proportion. So here's an example where I'm going to use 0.5. So here it is in Megastat. Don't forget to go to the tab that says sample size for proportions. So the bottom one here, don't worry about that one. The error that we're willing to have is 0.03. Don't forget to make it a proportion by moving the decimal place over. And since we don't have an estimate of the proportion, we just use 0.5 because that's going to give us the largest sample size if you look back into the equation. But you don't need to worry about that. Just use 0.5 if you don't have any estimate for the sample proportion P. Okay, and just hit OK, and I need a sample size of at least 1,068 students. Okay, so that's pretty high. I could probably lower that by having a little bit more error, maybe 5% error. So let's try that. Megastat, sample size, this time proportion, let's say I can do 5%, and I don't have an estimate of the sample proportion, so I'm always going to do 0.5 if I don't. And yeah, it goes way down, so 385 would be my sample size if I'm willing to have a little bit more error. Okay, here's another problem, and I've highlighted in yellow some of the things that would indicate what type of problem it is. So this insurance company is concerned about rising lab test costs and like to know the proportion of the positive lab tests for prostate cancer are actually proven correct through subsequent biopsy. So Jolly Blue Giant Health Insurance demands a sample large enough to ensure an error of plus or minus 2%. So the fact that the error is in percent, there's a percent sign for that error, tells you it's a proportion problem. And I'm willing to go with 90% confidence. So how big a sample do I need? Okay, so if we go to Megastat, sample size for proportion, I plug in 0.02 for my error. Again, I don't have an estimate of the sample proportion, so I just put 0.5 because that's going to give me the highest sample size, so that's the most conservative. Hit OK, and I need a sample of at least 1,691. Okay, notice if I want very little error, I need a big sample size. So we saw that when we upped the error, we didn't need as big of a sample size. Okay, let's look at this problem. A financial institution wishes to estimate the mean balances owed by its credit card customers. The population standard deviation is estimated to be 300. So notice this is going back to a mean problem. It's not a proportion problem. We also see that with the margin of error being $75 instead of a percent. So if a 99% confidence interval is used and an interval of $75 is desired, so basically margin of error plus or minus $75, how many cardholders should be sampled? Okay, let's go to Megastat. We've got an error of 75, 99% confidence, and the estimate of standard deviation is 300. Let's just go to a clean sheet. Megastat, confidence interval, sample size. We're going back to sample size mean problems, and we can see the error was 75. Confidence was 99. And my standard deviation estimate was $300. Okay, so 107 should be my sample, at least 107. So D would be the answer there. Okay, to estimate the average price of an iPad with a margin of error of $20 and confidence of 95%, standard deviation estimate of $100, what sample size should be used? So basically we have an error of $20, which I see is in dollars, so it's not a percent. Estimate of my standard deviation is 100 and 95% confidence. If I go back to Megastat, sample size mean, error of $20, standard deviation of $100, and back to 95% confidence. I need a sample size of 97, so not too bad, under 100 needed for $20 error. Okay, How about another proportion problem? To estimate the proportion of CU students who own an iPhone with a margin of error of 12% and a confidence level of 90%, what minimum sample should be used? Okay, so we've got margin of error of 0.12, confidence level of 90%, and if we don't have an estimate of the sample proportion, we just use 0.5. Okay, so remember this is a proportion problem. So we go back to sample size P, error of 12%, so put 0.12. Estimate of the sample proportion is 0.5 when I'm not given one, which I often won't have. And then moving the confidence to 90%. Only a sample size of 47. Okay, this is 12% error, fairly high, confidence fairly low, so I don't need a huge sample size. Let's see how it changes. Let's say I only wanted an error of 1% and I wanted to be 99% confident. How big is the sample size going to have to be? 16,588. So very small changes in the confidence and the error are going to change that sample size. So you can see, and you can kind of play with it. You know, if common confidence levels are 90, 95, and 99, and you don't have a lot of resources or time, you can probably go with that 90% and still be justified. I would say 1% error is maybe what you'd want to change instead of the confidence level. Or let's say, okay, 90% confidence. Let's say 95 because that's the most common. And I think my boss would be okay with 5% error. Okay, that's a little more workable. 385 for my sample. Okay, and that is it for that portion.